Garen Phillips here, and today I want to talk about parting lines and draft. I've got a few parts laid out here on the counter, and all these parts we make here in our foundry, except for this Xbox controller and that cardboard thing. But all these parts have a few things in common, and that is they all have parting lines and they all have draft. I want to explain what that is and why it's so important when making a mold or a casting or a pattern. This is a pattern for our bottom of our carb breather plate. This is the casting that's made from this pattern. And this right here is the parting line for the mold. The part is cut in half. You have the top side of the pattern, which is called the cope, and you have the bottom side, which is the drag. And the reason you have to have a parting line is because if you try to make a mold, there's no way you're going to get the pattern out without having it cut in half to be able to pull the mold apart. And I know that probably doesn't make sense. It's kind of something you have to see, and you can watch some of my later videos to get a better understanding of that. But the draft of your part is directly controlled by your parting line. Wherever you have your parting line, anything that's sticking out of your mold has to be drafted. And I know it's kind of hard to see, but if you look closely, these walls have angles on them. They aren't perfectly straight up. They aren't 90 degrees. And it's easier to see with the gating around the side. As you can see, there's a lot of angle on them. But this is called draft. And draft is used so that when you make the mold and you fill this with sand, you can pull the mold off of the pattern and you won't knock any sand loose, or your part won't get stuck. And there's different types of castings. This is green sand. You can also do air set or investment castings. These parts over here are die castings, which uses steel for the mold instead of sand. It's a lot faster. You can make a lot more parts with this, but they're more expensive to make the molds. And all these parts have parting lines and draft, and you can see that everything has an angle to it, a slight angle. And by being able to see the angle, you can tell where the parting line is for the part. And even this Xbox controller and cardboard box has draft on it because they were made in a mold. You can see the angles here, and they're angled in the inside, and the parting line for this is right here. And same for the Xbox controller. Everything is drafted. And this is a bit more complex. This is not a flat plane parting line. It's contoured all the way around the outside of the mold. So I won't talk about that too much. And these are some grenade shifters that we make. These also have parting line, and you can actually see this is the casting. You can see the parting line, and the casting was split right there. And the draft is in relation to the parting line. For the die casting, you can hold a lot less draft. I know that it almost looks like they're straight up, but they aren't. There is draft on these faces, and even the letters have draft on them. And this here is a green sand casting, and even these really small letters, they have a bit of draft on them and a radius. So it doesn't matter what size it is, you have to have draft whenever you design a part or design a mold. And I'll show you a better example on my computer here. Okay, so here I have a pattern board that I drew up really quickly, just with some basic shapes on it, some circles and whatnot, and I put a grenade in here just to show you a little bit more advanced drawing and how draft affects it. Right now I'm going to do a draft analysis, which is a feature on SolidWorks, the CAD software that I'm using. And what this does is I select the face that I want the pattern to be pulled. So the sand or the mold will be pulling up off of the board this way. So the draft is being calculated from that face. And as you can see, I have different colors, and the gradients show what the draft degree is for whatever face, and I can change the draft just by clicking this. And as you can see, here's the gradient, and about yellow is 2 degrees draft, so right here is about 2 degrees. So as you can see, these are red, which means that they are negative draft from the parting line. So these cannot be molded because there's no way that you'll be able to pull these out of sand without knocking sand into the mold. And you can also see here in the grenade, a bit more complicated drawing. You can see how it is affected by the draft. And right here, this face is about 1 degree, maybe a little less. You can go down and it'll show you. See, I'm down to 1 degree right here, and it's still red and yellow, which means it's not much draft on the face at all. But this analysis also works on cavities too. Right here, this circle, you can see as it keeps going up, I'm up to 40 degrees. You'll never have to design anything with 40 degrees draft, but I'm just showing you how it works in a concave circle. But one thing to note is that you want to ignore anything below the parting line, because all this doesn't matter because you're only checking this face. I can check the bottom face by just rotating around, and now it'll give me analysis on this bottom dome. And it's all green, so it all has positive draft. I can bring the draft down a bit. Alright, so hopefully that gives you a better idea of how parting lines and draft works. I'll run back through the parts one more time so you can see the draft. I will be making more videos on how things are manufactured, and I'll actually even go into designing an actual part and making it into a casting, how you can incorporate draft and parting lines into it. I wanted to keep this video simple just because it's the very basics of how it works. But if you like seeing how things are manufactured and designed, subscribe, like the videos, share them. I'll be making a lot more.